So I'd like to start the video with the finished product. This is an amplifier built for a customer who wanted a orange Tolix around the enclosure. I think it looks good. I like the orange Tolix. It gives it a rareness to the amplifier. We have the original Marshall type badge, a Plexi type badge with a Plexi front. Everything here is period correct. The EQ stage, everything is set at 12 o'clock except for treble. It's around 6 o'clock, and I like to have my customers start out with those settings. Loudness 1 is the master volume. Loudness 2 is the gain volume, gain. And I have the gain at 3 o'clock, around 3 o'clock. We have 4 inputs, input 2 and input 2 of input 2 high and input 2 low are non-functioning. These are non-functioning, and I'll explain why. We have high gain and low gain for 1 and 2. These are the functioning inputs. There's no need to have 4 channels because what one usually does is they jumper 1 and 2 and then insert their guitar here. This has all been done internally. This is a special circuit to make this amplifier sound exactly like the JTM45s from the 60s and right before 67. We'll take a look at the back next. And here's the view of the back. As you can see, we have a white plexi for the back, and this is again historically correct for the JTM45s from the early to mid 60s up to 67, I believe. And again, I do like this orange Tolix. I thought that would be not the greatest choice, but now I absolutely love it. I'd like to actually have one for myself. I'll have to build one for myself. So we can talk a little bit about the circuit. This is the power supply section. We have this potentiometer. This will allow us to use different types of output tubes such as the KT66, EL34, 5881, and the 6L6. This is the Sprague and Adam electrolytic capacitors that I really like to use. These are fantastic capacitors. And then you can see here, this is the paper and oil capacitor. This is a 0.1 microfarad. These are Russian military type paper and oil capacitors. These are used in fighter jets from the Russian Air Force. These paper and oil capacitors give a very open, bright sound. If you were to replace, let's say, these particular paper and oil capacitors coming from the phase inverter circuit into the grids of the output power supply or the output tubes, it's like lifting a veil or a wet blanket off your general sound. So I really like these. They're very robust, like I said. They are military grade, so they are, go through a lot of testing because they have to survive, so many G-forces. So these are great. I really like these a lot. Again, this is a 0.1 capacitor by Solon. I really like these. If you don't use these, because they can be a little noisy, I really highly recommend using the Solon type capacitor. Stay away from the orange drops. They sound horrible. And then as we move on through the circuit, we can see more paper and oil capacitors. These will go into the tone circuit, and these, are what they're really known for. Paper and oil is for the tone stack, that sound that people are looking for. I want to remind that when we do create circuits and amplifiers, we have two goals. Engineer technicians have two goals. One is to recreate the identical sound of the original circuit. So in this case, this is a JTM45. We're not trying to recreate something like or sort of like. We are recreating that sound exactly. And we have lots and lots of original JTM45s here, especially in California due to collectors. Many of the circuits still pristine and with the original capacitors. So we can analyze these circuits and have been doing so for many, many years at this point. Again, I do want to apologize for this part of the preamp circuit. These are, each engineer technician has his own way of recreating the identical sound. It's kind of a secret for most of us. We respect each other. We don't share other engineer technicians' variation to that. Again, we are trying to do two things. That is recreate the sound of the original circuit, and all engineer technicians are trying to make amplifiers, or we are making amplifiers that recreate the human voice. This is our ultimate goal, creating the human voice. So that's that. So I do again apologize for keeping this secret. This is of course my own variations, but this is the goal. Again, is to make sure that this sounds exactly like the original JTM45s from the 1960s and early 70s. So we're coming to the last steps of wiring the chassis, and it's just about time to focus back onto the circuit board, so let's do that now. And so here we are, we're going to go through the last steps of wiring up the circuit board. This is the underside of the circuit board. These wires will go to the tube sockets, and then up in here we're going to begin wiring in all the potentiometers. So let's do that now. We'll do that in gray wire. Let's begin. And so here we have the potentiometer wiring done. This is again a shot of the circuit board, the bottom side. And let's go ahead and move on to putting in finally the main transformer, the power transformer. So let's start with that. So we've got the power transformer and the output transformer. These are the wires for the output transformer here. On these wires as well. And then we have the power wiring here and here. So that's installed. We're going to begin wiring in the board now. We're going to start by wiring up all of the power transformers onto the board first, and then we'll move on to wiring up the output and preamp circuit section. So here we are, we have the chassis fully wired. There are some other components that need to be added, or wiring, such as this ground point. This is not fully soldered in because I need to add another ground wire from the circuit board. But this is pretty much done. So let's move on to circuit board. So at this point I'd like to talk a little bit about how to bias an amplifier. It seems like as I look on YouTube and seeing other technicians, their method of biasing an amplifier seems unusually complex and unnecessary. For example, you'll see technicians putting on measuring currents with voltage and modifying the amplifier with 1 ohm resistor at the cathode and so on and so forth. And this is really not how an engineer technician will bias an amplifier. So normally what a technician should be doing is placing his positive lead from his digital voltmeter in this location and or this location, and then of course his common will go to ground. And you're looking for somewhere between negative 38 volts to negative 48 volts. If you look at the schematic, design engineers have already predetermined the proper voltage. For an example, on this particular JTM45, design engineers have stated that negative 46 volts is the proper voltage. But I did leave out one factor, and that is when I bias an amplifier, I'm also using an oscilloscope, and I'll show you what I'm looking for, so please hold. Here's a proper way to bias an amplifier. We have a 1 kilohertz sine wave at 2 volts injected into the amplifier. We have an 8 ohm resistor attached to the speaker output, and we have our oscilloscope attached to that 8 ohm resistor. As we increase the master volume, you see the sine wave gradually going up, and what we're looking for is this little hump. This is the crossover distortion here. As I increase the volume, you see just this slight little hump here, and that's what you're looking for. You're looking for that very slight hump or crossover distortion. The design engineers have set the bias voltage for for negative 46, and you can see that that is really the proper negative bias voltage. So this is how an engineer will set the bias. So we're using a digital voltmeter to detect the voltage, but really the oscilloscope is the proper way to verify the proper bias. So we are now in the throes of final assembly. We'll go through the whole circuit and I will point out a few highlights. Let's start with the GZ34 rectifier tube. We have a 0.47 nanofarad capacitor going from pin 8 to ground. This is just for stability purposes. Moving on to the bias circuit, as I mentioned in the earlier clip, we biased this at negative 46 using a 1 kilohertz sine wave. I'll usually leave the sine wave injection on for approximately 15 minutes. This is just to help break in the amplifier, especially when it comes to not only the capacitors, but also the paper and oil capacitors. Again, you can use a Solon capacitor here. You can use the 0.022, this is 0.1 microfarad. A 0.022 I've seen in later models of the JTM45, that's appropriate. A Solon capacitor is a good brand, as I mentioned before. Mojotone is pretty good as well. I recommend not to use orange drop type caps, they suck. And there's some other high-end capacitors that you can try out, that's no problem. As you can see here, we have wiring for channel 1 and 2, 3 and 4. There's no connection. It's not necessary for this particular version of the JTM45, but we're going to keep this in for historical purposes, for the amplifier to look historically correct as possible. So we are in the throes of final assembly. I just wanted to show the cabinet needs to have copper shielding. You can use shielding of your choice, but always remember to have shielding in the cabinet. Here we can see that we have a white plexi back. This is historically correct for the JTM45. Here is the top view of the amplifier. Eric's Guitar Amplifier Repair, helping musicians to perform better.